Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. Today, I will discuss the solution of a problem that is taken from the GATE mathematics examination held in this year 2025. The question what I have taken is from the section Ordinary Differential Equations. This question is at the serial number 38 in the question paper, and it is related to the concepts of a very important concept, that is the Wronskian. This question is suitable for all these examinations. Right. The given question is, let y1 of x and y2 of x be two linearly independent solutions of the differential equation in brackets 1 plus x square y double prime minus x y prime plus cos square x multiplied by y, cos square x is in brackets, is equal to 0. This differential equation satisfies the initial conditions. y1 at 0 is 3, y1 prime at 0, where prime denotes the differentiation with respect to x. y1 prime at 0 is minus 1, and y2 0 is 0, y2 at 0 is minus 5, right? y2 prime at 0 is 2. These are the initial conditions given to us. Define w of x, the so-called Wronskian, that is equal to the 2 by 2 determinant, whose first row is y1 of x, y2 of x. Second row is y1 prime x and y2 prime x. Then the value of the Wronskian w at 1 by 2 is, we are given 4 options. This very rarely we come across the concept related to the Wronskian. Right. Let's now discuss the solution of the problem in detail. We are given the differential equation 1 plus x square into y double prime minus xy prime plus cos square x into y is equal to 0. We are given two linearly independent solutions, y1 of x and y2 of x, satisfying the initial conditions. y1 at 0 is 3, y1 prime at 0 is minus 1, y2 at 0 is minus 5, y2 prime at 0 is 2. We are given the Wronskian, denoted by w of x, of the solutions y1 of x and y2 of x. It is defined as the Wronskian w of x is equal to the 2 by 2 determinant, whose first row is y1 of x, y2 of x. Second row is y1 prime x and y2 prime x. To work out this problem, we have to recall this theorem, that is Abel's theorem on Wronskians. Theorem states, for a second order homogeneous linear differential equation, y double prime plus p of x into y prime plus q of x into y is equal to 0. You have to specifically note down that the coefficient of y double prime, you have to make it 1. For this differential equation, the Wronskian of two solutions y1 and y2 satisfies the following relation. The Wronskian of y1, y2 at x is equal to the Wronskian of y1, y2 at the initial point x0 multiplied by e power minus integral the initial point x0 to x of pt dt, where p of x is the coefficient of y prime in the given differential equation, making the coefficient of y double prime must be 1. If it is not 1, make it 1. Then you take the coefficient of y prime, that as px. Right. So this is called the Abel's theorem on Wronskians. We return back to our given question, where the Wronskian of y1, y2 at x0 is the initial value of the Wronskian. Good. Right. We return back to our question. By Abel's theorem on Wronskians, we have the Wronskian at y1, y2 of x is equal to x is any point in the interval, is the Wronskian of y1, y2 at the initial point. In our case, the initial point is 0, multiplied by e to the power of minus integral 0 to x, x0 is 0, 0 to x, p of x. P of x is minus x by 1 plus x square. Minus x by 1 plus x square. So minus t by 1 plus t square dt, integral 0 to x. Right. We continue in the next slide. So we want to find the value of the Wronskian at 1 by 2. We are given 4 options. We have, by Abel's theorem on Wronskian, brought forward from the last slide. So this is what we have. Right. This is the Wronskian of y1, y2 at x is the Wronskian w of x is equal to the Wronskian of y1, y2 at 0 is the determinant y1 at 0, y2 at 0, first row, y1 prime 0 at y2 prime 0, multiplied by e to the power of minus into minus plus integral 0 to x, x by 1 plus x square. When you integrate, it will be 1 by 2 ln of 1 plus t square to be evaluated between 0 to x. So what are these initial values? We have not brought from the last slide. Yes, we are here. So these are the initial conditions given to us. So y1 0 is 3, y2 0 is minus 5, y1 prime 0 is minus 1, y2 prime 0 is 2. Substitute. Agreed. To e to the power of, when evaluated this one between the limits 0 to x, it is 1 by 2 ln of 1 plus x square for the upper limit. For the lower limit, ln of 1 will be 0. So this is it. So e to the power of 1 by 2 ln of 1 plus x square is under the square root of 1 plus x square. And the value of this determinant when evaluated is 3 2s are 6 minus 5, that is 1. So the Wronskian value we got, w of x is equal to under the square root of 1 plus x square. We want the Wronskian value when x is equal to 1 by 2, substitute here, is under the square root of 1 plus 1 by 2 whole square, and that is equal to under the square root of 5 by 4, and that is root 5 by 2. Let's look at our options. Root 5 by 2 appears against option B. Therefore, option B is true. The answer to this question is option B. That is the detailed discussion of the solution of this problem, wherein a very important concept called the Wronskian is used, and a very important result related to Wronskian, that is the Abel's theorem on Wronskians is used. Right. And my dear students, I have been telling you, whenever you study one problem, I used to tell you that what are the concepts that are there, what are the theorems you have used, and the related ideas and the related questions you solve and make it a good notes, and that will be helpful for you in future. That I have been telling you. So I will tell you a model here in this context. The model is, I make a notes. First, what do you mean by the Wronskian? The Wronskian is defined for n differentiable functions on interval I. Smooth functions also you can say. Right. And what are the properties of the Wronskian and the results related to Wronskian? So gather all those ideas. A very important property where Wronskians are used for deciding, the given functions, whether they are linearly independent or linearly dependent on an interval I. And many times we talk about linear dependence and independence of differential equations also. Right. So, A, if the functions are linearly dependent on an interval I, then if they are linearly dependent, then the Wronskian is identically 0 on that interval. No, read carefully. Is one way. Linearly dependent. If they are linearly dependent, then the Wronskian is identically 0 on that interval. That means at every point it should be 0. B, if the Wronskian is non-zero at any point, at one point in the interval I, then the functions are linearly independent on the interval I. It's about Wronskian being non-zero at a point in the interval I, then the functions are linearly independent. And a theorem related to that is the Abel's theorem in the context of differential equations, which I have used. And here, if the initial Wronskian, that means the Wronskian evaluated at the initial point, is non-zero, then the solutions are linearly independent. This result is also there. If the initial Wronskian is 0, that means the Wronskian value at the initial point is 0, the solutions are linearly dependent. This is also there. And people think that this property E is not true, but it is true. And to establish such a kind of result, you have to use Abel's theorem. Like that. So, catch hold of all the concepts related to the Wronskian and work out some problems and make a good notes of it. That will be helpful to you. So, with this, yes. Here is a problem for your homework. What's the problem? Consider the ordinary differential equation y double prime minus p of x into y prime plus q of x into y is equal to 0, where p of x and q of x are smooth functions. Here, by mistake, I have written as minus. This is plus only. This is plus only. They are smooth functions on an interval I. Let y1x and y2x be two solutions of the ordinary differential equation, and w of x be the Wronskian of y1 and y2. Then which of the following is always true? we are given four options. Option A, if y1, y2 are linearly dependent, then there exists points A, B belongs to I such that the Wronskian at A is 0, but the Wronskian at B not 0. Option B, if y1, y2 are linearly independent, then the Wronskian is 0 for all x belongs to I. Option C, if y1, y2 are linearly dependent, then the Wronskian is not 0 for all x belongs to I. Option D, if y1 and y2 are linearly independent, then the Wronskian is not 0 for all x belongs to I. So what is necessarily true out of these four options? Work out and write your answer in the comments section. Please write your answer under the comments, and I am sure that you will be writing its answer under comments. I will be very happy if many of you, if all of you answer this question. I will be very happy for that. I am sure you will do it. With these few words, we have to close down the video now. I am sure that you have understood the concept of the Wronskian, the properties of Wronskian, and the question that has come in the GATE examination and its solution. And you work out that problem which I have left for you for the homework. Write your answer under comment section. Right. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am pretty sure that we will be meeting once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.